Hey guys, welcome back to my YouTube channel. My name is Bhanu Chandra and I'm studying in Sri Venkateswara College of Engineering. I'm a first year engineering student and this is my mathematics video assignment. My USN is 1V23CD007 and today we'll talk about the subject Mathematics 2 for CSE stream. So the subject code for this subject is BMATS 201. So today mainly we'll talk about the topics like scale factor, base vector, and orthogonality condition for cylindrical coordinate system. So moving on. So content of these videos are listed below. So first we learn about vectors, introduction to vectors, what are vectors, some basics of vector. Then we'll go with scale factor, what is scale factor, formula for scale factor. Then base vector and orthogonality condition for the cylindrical coordinate system. And then finally we'll apply everything in cylindrical coordinate system. We'll find base vector, scale factor and orthogonality condition and we'll prove it. So first, introduction. What is a vector? So basically a vector is a physical quantity which has both magnitude and direction. For example, acceleration, velocity and force, they have both magnitude and direction. So if direction changes, their value may vary. So some basics of vector are, vector representation. Let I cap, j cap and k cap are the unit vectors along x-axis, y-axis and z-axis respectively. Then the vector is defined as a bar is equal to a1 I cap, a2 j cap and a3 k cap. So magnitude of the vector can be given by modulus. It is represented by modulus of a bar, which is a1 square plus a2 square plus a3 square. So moving on, the next topic is scale factor. What is a scale factor? So let's study about detail in. So let us consider a position vector r bar is equal to u1 I cap plus u2 j cap plus u3 k cap. Let this be a position vector of some point in space. Therefore, r bar has three quantities in x and x, y, z axis, which is r bar u1, u2 and u3. So the tangent vector for u1, u2 and u3 with respect to r bar is partial derivative of r bar with respect to u1, partial derivative of r bar with respect to u2 and partial derivative of r bar with respect to u3. So the scale factor is represented by h1, h2 and h3 and can be given by the tangent vectors. So h1 is given by modulus of r bar, modulus of partial differentiation of r bar with respect to u1, which is magnitude of this vector, this differentiation. So similarly h2 is equal to dou r bar by dou u2 and h3 is equal to dou r bar by dou u3. So the next one is base vector. Uh, so the base vector for the previous scale factor is given by E1 bar, E2 bar and E3 bar. So the formula for E1 bar is equal to 1 by H1 into partial derivative of R bar with respect to U1. So which is similar to dou R bar by dou U1 divided by magnitude of the partial derivative. So similarly E2 cap is equal to 1 by H2 into dou R bar by dou U2 and E3 is equal to 1 by H3 into dou R bar by dou U3. So which is 1 by scale factor into partial derivative of the given axis, which is U1, U2 or U3. So for the orthogonality condition, after finding E1 cap, E2 cap and E3 cap, we can find the orthogonality condition. So after finding E1, E2 and E3 cap, the curve is said to be orthogonal if E1 dot E2 is equal to 0 or E1 dot E3 is equal to 0, E2 dot E3 is equal to 0. If all these three vectors are equal to 0, the dot products are equal to 0, then we say that the curve is orthogonal. So now we'll apply all the scale factor, base vector and condition of orthogonality in the cylindrical coordinate system. So the scale factor of cylindrical coordinate system. So the cylindrical coordinate system, the three axis points are represented as rho, phi and z, given by the transformation of x equal to p cos phi, y is equal to p sin phi and z is equal to z. So let's consider a position vector r bar is equal to xi cap plus yj cap plus zk cap. If we substitute the value of x, y, z, which is p cos phi, p sin phi and z in the position vector, we get r bar is equal to p cos phi I cap, p sin phi j cap and zk cap. So, by the definition of scale factor which we saw in the previous slides, h1 is equal to magnitude of dou r bar with respect to u1. Here u1 is rho. So, if we should differentiate the position vector with respect to rho, so we get cos phi I cap plus sin phi j cap. So, if we find the magnitude of this vector, which is root of cos square phi plus sin square phi, which is equal to 1. So, the value of h1 is 1. So similarly, to find the value of h2, we find modulus of dou r bar by dou u2, where u2 is phi. So if we differentiate the position vector with respect to phi, we get minus rho sin phi I cap plus rho cos phi j cap. So if we find the magnitude of this vector, we find root of rho square cos square phi plus rho square sin square phi. If we take cos square phi and sin square phi common, which is equal to 1, so we get under root rho square, which is equal to rho. So similarly for H3, it is a modulus of dou r bar by dou u3. Here u3 is equal to z, so we should differentiate r bar with respect to z. So the differentiation of r bar with respect to u3 is 1 k cap. So modulus of this is root of 1 square, which is 1. So the value of h1, h2 and h3 is found. So for the base vector, h1, h2 and h3 is found from the previous slide. So base vector can be given as e cap is equal to e rho cap is equal to 1 by h1 into dou r by dou rho, which is cos phi I cap plus sin phi j cap divided by 1. The value of h1 is 1. So cos phi I cap plus sin phi j cap. So the value of e rho is cos phi I cap plus sin phi j cap. For E psi, E phi we get 1 by h2 into dou r bar by dou phi, which is minus rho sin phi I cap plus rho cos phi j cap divided by h2 value is rho. So we get cos phi j cap minus sin phi I cap. So rho z is equal to 1 by h3 into dou r bar by dou z, which is the value of dou r bar by dou z is k, and value of h3 is 1. So Ez value is 1 k cap. So for the condition of orthogonality of cylindrical coordinate system, we have to prove that the dot product of E rho cap, E phi cap and Ez cap is equal to 0. So for first, E rho cap dot E phi cap is given by a dot product of cos phi I cap plus sin phi j cap into cos phi j cap into sin phi I cap. So which is 0. For next we have E phi cap and Ez cap, which is equal to cos phi j cap minus sin phi I cap into 1 k cap, which is again 0. And Ez cap into E rho cap is equal to 1 k cap into cos phi I cap plus sin phi j cap. So dot product of all the three are 0, which is E rho cap and into dot E phi cap is equal to 0. E phi cap into Ez cap is equal to 0. Ez cap dot E rho cap is equal to 0. So hence the cylindrical system, cylindrical coordinate system is proved orthogonal. So that's it for today's video. Thank you for watching. Please like my video and hit the subscribe button. And if you have any doubts, comment down in the comment section. Thank you for